Hi, and welcome back to the second section of our course, Working with Strings. In our last section, we got our development environment set up and ready to develop some Python, and we got some basics about the Python language. In this section, we'll learn much more about format strings and how and when to use them. We'll learn many string parsing techniques to decompose user input into useful parts that we can work with, including regular expressions, a very powerful parsing tool that's used to recognize specific patterns in the text. We will learn how to work with dates, both for printing them as well as parsing and manipulating them from user input. We'll use the hashlib library to try out some security applications as well as data integrity applications. And finally, we'll learn how to read and write to a file, as well as how to encode and decode byte sequences into meaningful data. This is the first video of the section, Printing and Formatting Strings. In this video, we will learn how to print strings with alignments and padded widths that we can specify in order to create a nice textual output. We will also look at the different numeric format specifiers and what we can do with them. And finally, we'll take a look at Python 3.6's new format string type that can allow us to quickly and cleanly write format strings using our local namespace variables without having the overhead of a .format specifier. In Python, there are primarily three distinct types of format strings. The first type, unnamed positional arguments, simply uses empty curly braces and replaces them with the words in the format specifier in the order they're encountered. The second type, named positional arguments, explicitly calls out which index to use for which place. In this case, we replace 0 with the 0th index and 1 with the 1th index. The third type is named arguments. This is the primary format string specifier that we'll be using in this course. It's very explicit. Here we explicitly say what the variable names are, and then we explicitly place them into our format specifier. The last type is format strings that were introduced in Python 3.6. In this case, we can use our variable that we have defined in our local environment and just print it directly without having to say .format. Alright, let's take a look at what some format descriptions might look like. In this instance, we want to print our variable named A over here, which will be substituted with the word test. Initially, we want it left aligned with a padding of 10. This indicates left alignment. This is the padding of 10. Second case, we want to print it, again with a padding of 10, but this time with the up arrow, we indicate that we want it to be centered. And lastly, the same thing with a padding of 10, but we want it to be aligned to the right, as indicated by the right arrow. Additionally, we can use a fill character. We're going to go ahead and use tilde. Again, you can really use any character you want, but in this case, we just went ahead and used tilde. So this is going to fill our padding with tildes in all three cases. When we go ahead and run this, we'll see initially left alignment, center alignment, right alignment, and in the second case with tildes as our padding character. Additionally, you can access keys and attributes of complex items. In this case, person has a first and last name, which we can then access from within our format string. Additionally, you can access array indexes. Here's an array, and we'll just print some indexes of it. Now when we run it, we'll go ahead and we'll see that we print first and last name, and we print some indices from our list. Alright, let's talk about how we can print numbers now. You can just print a number by specifying an integer with the D specifier, a float with the F specifier. You can convert an integer into binary. You can also specify width and padding with numerics. So here, we'll pad it 8 with 8 and 0 as our fill character. You can use X as the hex specifier. And again, you can use standard alignment and padding techniques with the string. You can use O to print things octally. Now, when we go ahead and run this, we'll see all our different variations of integers. We see int as float, we see binary, padded hex, padded hex, and octal. Let's talk about floating point numbers. Consider the following. This is just a representation of pi, but when we print it, you'll see we have an awful lot of decimal places. If we only wanted 2 decimal places, like currency, you could simply specify a 0 padded, truncate it at 2 decimal places, float. There we go. It looks just like currency. If we wanted to print it in scientific notation, we could just use the E specifier. You see, it's in scientific notation. And if we wanted to print it as a percent, we'd just use the percent specifier. Lastly, if you want to truncate it at just a reasonable place without having to specify the actual precision, you can use the G specifier. But in general, that's not really recommended. You notice that it truncates all these 0001s. Now if we put some significant digits in there, we see it doesn't truncate those, but it truncates all the insignificant ones. Lastly, new in Python 3.6, we can use the F format strings to substitute in local variables. So if we say variable equals 27, we can simply say print F variable. Since we use this F specifier, we can access this variable directly without having to add the dot format and the number. And we do see it prints 27. Well, that just about covers our introduction to format strings. There's a lot more to them, and I really encourage you to check out the official Python documentation online.